Okay, so in this lesson we're going to be studying simplifying radicals, and so this is a continuation of radicals from a previous lesson. But the focus here will be strictly on square roots, and we're going to be looking at what's called the product rule. So when we talked about simplifying radicals in the previous lesson, we didn't talk about the product rule, but now we're going to need to talk about that. Let's first of all review something from a previous lesson, and just to let you know that a square root simplified when the radicand contains no perfect square factors other than 1. So again, as we go through the process, as we're using the product rule, a square root is simplified. So this is what I mean by when a square root is simplified, that the radicand contains no perfect square factors. All right, so remember your perfect squares. So I use the word perfect square here. So remember your perfect squares. Your perfect squares are, remember the smallest one is 1. This next one, remember, is 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49, and so on. So there's an infinite number of perfect squares, but 1's the smallest perfect square. And remember, when we take the square root of all these perfect squares, we get a whole number back. Square root of 1 is 1, square root of 4 is 2, the square root of 9 is 3, square root of 16 is 4, and so on. Okay? So in a previous lesson, though, when we talked about these, when we talked about simplifying square roots, we looked at these situations, though. So those were the easier kind. So we looked at something like the square root of 81. All right, and notice that 81 is a perfect square. I just didn't have it listed, but it is a perfect square because 9 times 9 is 81, right? And so when I take the square root of 81, I know that's 9. And remember, you know it's 9 because in your mind you're thinking 9 times 9 is the radicand, 81. All right, so in the previous lesson, these radicands are perfect squares. But what about if I ask you to do this? If I ask you to simplify the square root of 12. Well, obviously 12 is not a perfect square. 12 is not listed here. There is no positive whole number. There is no whole number times itself that is 12. Okay? So to simplify this, remember a square root simplified when the radicand contains no perfect squares other than 1. So remember, 1 is a factor of every number. So obviously there is a perfect square that goes into all of these radicands, and it will be 1. But if you look at all the other perfect squares, which of these other perfect squares will go into 12? Well, 4, right? So there is a perfect square. There is a perfect square listed other than 1 that I can use to simplify the square root of 12. Okay, so that's going to be the idea. All right, now, we're going to come back and do this in a little while, but I need to talk about the product rule now. So let's talk about the product rule. Okay, so we know this. We know that the square root of 4 times 9, square root of 4 times 9 is the square root of 36. 9 times 4 is 36. And since 36 is a perfect square, then that's just equal to 6. Now, some students make a mistake, and I got to remind you of this. Some students make a mistake, and they say, and this happens quite a bit, they say the square root of 36 is the square root of 6. That's not true, okay? Because remember, when we talked about simplifying square roots, whatever you put here, you need to ask yourself, is this times itself the radicand? 6 times 6 is 36. The square root of 6 times the square root of 6 is not 36. The square root of 6 times the square root of 6 is 6. All right, so be careful. The square root of 36 is strictly 6, not the square root of 6. So be careful as you go through this, okay? All right, now, let me go a little bit further with this. We also know that the square root of 4 times the square root of 9, and remember the square root of 4 is 2, the square root of 9 is 3, 2 times 3 is also equal to 6, right? So those are equal to each other. So what that means is this. If the square root of 4 times 9, so this implies that the square root of 4 times 9, if that's equal to 6, then the square root of 4 times 9 is also equal to this right here. The square root of 4 times the square root of 9. And it is, because both of those are equal to 6. So what that implies is this. Whenever you have the square root of a product of factors, in this case I only have 2, but you can have more than 2. Whenever you have a product of a square root and the radicand is a product of factors, then you can write it as the product of the square root of every factor you see. Okay? So that means the square root of 4 times 9 is the square root of 4 times the square root of 9. All right? So in other words, listen carefully. In other words, if I have the square root of, and remember, I'm going to put some of those not perfect squares just to show you. So if you have the square root of 3 times 7 times, let's say, 8, then that means that can also be written as the square root of 3 times the square root of 7 times the square root of 8. That's what that means. That's what this discussion is implying. And so that's called the product rule for square roots. So let's talk about the product rule for square roots. So product rule for square roots. All right, so here's a product rule for square roots. So basically it says this. If you have the square root of a product, a times b, just like this, see this right here, a times b, 4 times 9, then I can write this as the square root of a times the square root of b. Okay? Now, that is true for as long as a and b are, well, the square root of a, the square root of a and the square root of b are real numbers. Okay, so the square root of a and the square root of b are real numbers. All right, and notice the square root of 4 is a real number, the square root of 9 is a real number. The square root of 3 is a real number, the square root of 7 is a real number, the square root of 8 is a real number. Okay? So in other words, in order for the square root of a to be a real number, a cannot be negative. Because remember, square root of a negative 5 is not a real number. All right, so that's all that's implying. So b cannot be negative. All right, so as we go through these problems, you're going to notice that the radicands are all positive. The radicands are all positive. So in order to use this rule, the radicands need to be positive. Okay. All right. Now let's go back to this example here. So we'll go back to square root of 12. So the directions will say simplify the square root of 12, or simplify. Now let me say this also. Sometimes, now listen, sometimes the directions, depending on your textbook, sometimes the directions will say just simplify. Sometimes it may say this: simplify using factors. Simplify using factors. And so I'll explain what that means in a little while. But simplify using factors. Okay, so number 1, square root of 12. All right, so first of all, ask yourself, is 12 a perfect square? The answer is no. There is no whole number times itself that's 12. Now you got to ask yourself, is there a perfect square? Is there a perfect square other than 1 that goes into 12 evenly? The answer is yes. What perfect square goes into 12 evenly? 4. All right, so then I'm going to use the idea of the product rule. So that means this. Okay, so you're going to write it like this. You're going to say, all right, well, that's going to be the square root of 4 times the square root of 3. And then listen, this is the way that I write it, which always usually helps students. Always put the perfect square first. You could write it as 3 times 4. You can definitely say 3 times 4, but always put the perfect square first. Okay? And so I'm going to put something right underneath. So now since I have the square root of a product, and by the way, this is what they mean by using factors. See, I wrote 12 as a product of factors. 4 times 3, that's what that means. Okay, so then I get the square root of 4 times the square root of 3. And then notice now, since 4 is a perfect square, I know that the square root of 4 is 2. 3 is not a perfect square, and what's the only perfect square that goes into 3 evenly? What's the only perfect square that goes into 3 evenly? It's just 1. So then you can't simplify the square root of 3 any further, so this is your answer. So the answer is 2 times the square root of 3. So you simplified the square root of 12. The square root of 12 is 2 times the square root of 3. So it's very important as you go through your process, as you rationalize how to deal with these, that you write out this part, okay? And so you look at each factor at that point. So the square root of 4 is 2. The square root of 3, I can't simplify that any further because the only perfect square that goes into 3 is 1. And so that's all you have, okay? All right, number 2. Let's look at number 2. So number 2, we have the square root of 90. So we're going to simplify the square root of 90. So let's look at our perfect squares. So other than, and let me go ahead and write the perfect squares over right here. So these are, remember, your perfect squares, and they're an infinite number of perfect squares. So 1, 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, and so on. Okay? All right. So to simplify the square root of a whole number, you want to look for a perfect square that will divide into 90 evenly. Okay, so 1 is a factor of all these radicands. So what I would do is I would just take your calculator and then just start with 4. Just start with the next one. And so these are not going to be too outrageous to where you can't just use this idea here. So you just say 90 divided by 4 and see if you get a remainder 0. And I don't, because I get a decimal here. All right, so it's 22 and some remainder. All right, let's go to 9. So 90 times 9. Oops, sorry. I'm sorry. 90 divided by 9. And I get 10, right? Okay, now before you go 1, here's what I mentioned earlier. You should always use the largest perfect square. It helps if you use the largest, okay? So when you say 90 divided by 9, so remember 90, I'm going to write it out. 90, remember, is 9 times 9, right? 9 times 10. 9 is a perfect square. Now, before you go any further, see if 9 is the largest perfect square. Is there another perfect square other than 1 that goes into 10? No. So 9 is the largest perfect square. So now what you can do is this. So 9 is the largest perfect square. The largest perfect square. Okay? So always use the largest. So I'm going to write this as the square root of 9 times 10. See that? Then I'm going to use the product rule. So according to the product rule, that means I can write this as a product of square roots of each of those factors. So that's the square root of 9 times the square root of 10. And I know the square root of 9 will be 3. And the square root of 10, I cannot simplify any further. So the answer is 3 square root of 10. Okay? All right. So remember, a perfect square is simplified when the radicand contains no perfect square other than 1. So if I look at the square root of 3, the square root of 10, is there another perfect square other than 1 that will divide into 10 evenly? No. Okay? All right, number 3. And that's all it is. That's all you do to simplify square roots. Okay, now remember, the square roots in this lesson only contains whole numbers. In another lesson, and you got to master this first, in another lesson we're going to look at problems where there are variables. Okay, number 3, let's suppose we had the square root of 54. Okay, square root of 54. Okay, again, let's use our calculator and then go through the process. Let's do 4 first. 54 divided by 4. Okay, it's not a, so 4 does not go into 54 evenly because I get a remainder. So let's look at 9. 54 divided by 9. There we go. All right, now, so I know this. I know 54 is 9 times 6. But remember, it helps if you always use the largest perfect square. So the question is 9 the largest? Well, look at 6. Besides 1, will any of these other perfect squares divide into 6 evenly? No. So 9 is the largest. So that's the largest perfect square. So that's your largest perfect square, right? Okay, so that means then I'm going to rewrite this as the square root of 9 times 6. And again, always put it helps if you put the largest, I'm sorry, it helps if you put your perfect square first in this product. So I wrote 54 as a product of factors. And one of those factors is a perfect square. Okay? One of those factors is a perfect square. So now I'm going to use a product rule. So remember the product rule. So now I'm going to use a product rule. And so that means then I can rewrite this as a product of the square root of each of those factors. So the square root of 9 times the square root of 6. And now let's simplify. The square root of 9, since 9 is a perfect square, the square root of 9 is 3. Now don't say the square root of 3. It is 3, right? Okay. And then the square root of 6, remember, make sure you can't simplify the square root of 6 any further. And you cannot in this case because 1 is the only perfect square that goes into 6. And so your answer is 3 square root of 6. All right, number 4. And that's all you're dealing with. That's all it is. Number 4, you have the square root of 40. The square root of 40. All right, so again, same idea. So which of these perfect squares other than 1 will go into 40? And always try and use the largest first. So let's do the next one I see, 4. So 40 I know is 4 times 10, right? And so I know 4 is a perfect square. Now let's see there's another perfect square that goes into 10 other than 1. And there isn't. So that's going to be the largest. So that means I can write square root of 40 as the square root of 4 times 10. And then I'm going to use the product rule. So that's the square root of 4 times the square root of 10. And then the square root of 4, since 4 is a perfect square, the square root of 4 is 2. I cannot simplify the square root of 10 any further. So the answer is 2 square root of 10. And always remember, see how I'm writing this? Always put the monomial factor first. Put the square root on the end. Okay? So don't write it as this. So don't write it as the square root of 10 times 2. Don't do that. Even though mathematically these two are correct, we always put the monomial factor first. Okay? All right, number 5. Let's suppose in number 5 I have the and let's say it's this one. All right, so let's say it's the square root of 72. Square root of 72. All right, so let's go through the process again. Other than 1, let's see which of these perfect squares go to 72. And remember, you always want to try to use the largest one. It helps. It saves a lot of steps whenever you use the largest one. All right, so let's see if 4 goes into 72 evenly. So I'm going to say 72 divided by 4. And I get 18. So it does, right? So I know this. Now listen carefully. I know this. I know 72 is 4 times 18. 4 is a perfect square. But is it the largest, though? Remember, we always look to see if we could find the largest because it helps. All right, so is it the largest? Well, no, because look at 18. Is there another perfect square listed that will divide to 18 evenly? Yeah. Which one? 9. So that means this. Now look, I'm writing this. That means that this is 4 times, and then 18 would be 9 times 2, right? And so if this is a perfect square, and this is a perfect square, and you multiply them together, their product is going to be a perfect square. So that means 4 times 9 is 36, and so 36 times 2 is 72, and notice 36 is a perfect square. So I'm going to say it again. If you multiply 2 perfect squares together, their product is also a perfect square. And then notice that 2, I cannot, there's no perfect square other than one goes into 2, so 36 is the largest. So what that means is this, okay? Whenever you use the largest, it helps you because look, this is the square root of 36 times 2, right? And then using a product rule for square roots, that means I can write this as the square root of 36 times the square root of 2. And so we know that since 36 is a perfect square, we know that the square root of 36 is 6. So I get 6, and then I cannot simplify the square root of 2 any further, so the answer is 6 square root of 2. Okay? Now, if you had not use the largest perfect square, here's what you have to deal with. Okay, so listen to the discussion. The square root of 72, let's say you used 4. And so you said, all right, that's going to be the square root of 4 times 18, right? Okay, no big deal. I'm okay with that so far. All right, using the product rule, I get the square root of 4 times the square root of 18, correct? And so since 4 is a perfect square, I get 2 square root of 18. But remember our statement at the beginning, a square root is simplified when the radicand contains no perfect square factors other than 1. So when I go back over here and I ask myself, are there any other perfect squares listed that will go to 18 evenly besides 1? And the answer is yes. What? 9. So then you have to go further. You have to go further. So that means then, all right, I'm going to have to write this as 2 now times the square root of 9 times 2. And so now I have to use the product rule on this again. So this becomes 2 times the square root of 9 times the square root of 2, right? And so since 9 is a perfect square, this becomes 2, and the square root of 9 is 3. I cannot simplify the square root of 2, so that stays the square root of 2. And then 2 times 3 is 6. You get 6 square root of 2, which is what we had here. So notice, guys, how much easier it is to have used the largest perfect square first. So if you're not sure, if you found the largest perfect square when you go through this process, then do what we just did here. So you can say 4 times 18 is 72. Then you ask yourself, is there another perfect square other than one to go into 18? And the answer is yes, 9. And so I get 4 times 9. There is no perfect square that goes into 2 other than 1. And so if you're multiplying 2 perfect squares together, their product will always be a perfect square. And so you found the largest now, and then you use it. If you just go through this process, look how many steps you have to go through before you end up with the square root of 72 simplified. This is simplified. This is not the answer. Why is this not the answer? This is not your answer, not the answer. It's not the answer because it's not simplified. Because it is not simplified. All right, so remember, simplified means that the radicand must contain no perfect squares other than perfect square factors other than 1. So notice 18, there is a perfect square that goes in 18. It's 9, so you got to go further. Okay? All right, so let's look at another one. So let's look at number 6. So see, it's not that bad, right? And so knowing this, though, will help you when we do the part with the variables. So all of this builds upon each other. Okay, number 6. Let's say we had this for number 6. We had the square root of, well, let's do this. Let's say we had 2 times the square root of 24. Okay, so don't let the fact that there's a factor of 2 involved here as well. We even did one while ago, didn't we? Did we do this? And we know how to deal with this now. So we know how to deal when it's not just a square root of 90 or the square root of 54 or the square root of 40. We know how to deal with it when we have something like 2 times the square root of 18. So basically, you're going to rewrite the 2. So remember, these are all factors, 2 and then the square root of 24. Now I've got to ask myself, can I simplify the square root of 24? So is there a perfect square? So is there a perfect square other than 1 that goes into 24 evenly? All right, so let's try see if 4 goes into 24, and it does, because 24, remember, is going to be 4 times 6. Now let's talk about 6. Other than 1, is there any other perfect square that goes into 6 evenly? No. So I found the largest. This is the largest right here. So then I'm going to rewrite this as the square root of 4 times 6. And then you use the product rule. So use the product rule for square roots. So the product rule says, all right, if I have the square root of a product of factors, then I can rewrite this, don't forget the 2, then I can rewrite this as the square root of the as a product of the square root of all these factors. So meaning the square root of 4 times the square root of 6. And so let's simplify the square root of 4. The square root of 4 is 2. So I get 2 times the square root of 6. And so therefore the answer is 4, because 2 times 2 is 4, square root of 6. That's the answer. And notice you simplify this because I can't simplify the square root of 6 any further. The only perfect square that goes into 6 is 1. All right, so that's number 6. Number 7, let's suppose we had this, number 7, we had negative square root of 98. Negative square root of 98. Okay? So let's go through the process. Let's go through the process and see if I can find a perfect square other than 1 that goes into 98. All right, so we have, let's try 4. 98 divided by 4. Let's see what we get. Okay, notice 4 does not go to 98 evenly, so I move on. Let's try 9. 98 divided by 9. Not evenly either, right? So let's go to 16. 98 divided by 16. Okay, and I'm going to say this. If I knew that 4 did not go to 98 evenly, then obviously 16 will not do either, because 4 is a factor of 16. So I did not have to try 16 because I knew it would not be a factor of 98, because 4 is not a factor of 98. So since 4 is a factor of 16 and 4 was not a factor of 98, then it definitely will not be a factor of 16 will definitely not be a factor of 98. All right, now obviously you all know that 25 will not go to 98 evenly. Okay, let's try 36. So 98 divided by 36. Nope. Let's try 49. 98 divided by 49. Yep, there we go. All right, so 98 we know is this. So 98 we know is 49 times 2. And 2, there is no perfect square other than 1 that divides into 2 evenly. So there's the largest right here. This is the largest. So therefore I'm going to rewrite this as negative square root of 49 times 2. And now I'm going to use a product rule. And so the product rule, I'm going to have negative square root of 49 times the square root of 2. And so since 49 is a perfect square, I know that the square root of 49 is 7. So the answer is negative 7 square root of 2. There's your answer. Okay? So don't forget the negative though. All right. Let's look at this one, number 8. Number 8, we have the square root of 65. Square root of 65. All right, so let's look at what we have. So notice the last digit's 5, right? So think about your divisibility rules. So if the last digit's 5, then that means that the in order for it to have a factor, then I need to have my last digit being 5 as well, right? So notice I know that 4 won't go to 65 evenly. So 65 divided by 4, okay? 16 either. Now here's a digit with 5 on the end, but you know that won't either, because the multiples of 25 are 25, 50, 75, and so on. And so notice you only have to go halfway of this number. So the 65 divided by 2 is 32. So just go up to 16 and you're done. So notice there, besides 1, there is no perfect square that goes into 65. So what you would say is that this can't be simplified further. Can't be simplified further. Okay, or some people will just say can't be simplified. Okay, so now you could write this and you're fine, because you can't this cannot be simplified. Now sometimes though, if it's a multiple choice, they may have the word can't be simplified, and so you'd circle it. Sometimes they would have as the choice this itself. So what I'm trying to say is this. See how we said here? Let's go to this one right here. So when we said here that 2 square root of 24 was equal to 4 square root of 6, right? Okay. Here you could also, now usually we'll just say cannot be simplified, but you can in depending on what the assignment looks like, you could also say this: the square root of 65 is equal to itself. All right, so basically, I can't. The square root of 65 cannot be simplified any further, so there it is. So that is my answer: square root of 65. Okay. All right. Number 9. Let's suppose we had, let's see, negative 6 square root of 18. Negative 6 square root of 18. All right, so let's look at 18. So we know we can simplify the square root of 18 further, because what perfect square listed here other than 1 goes in 18? 9. So 18 is 9 times 2, right? And so 9 is the largest, and so I'm going to rewrite this as negative 6 times the square root of 9 times 2. And then let's use the product rule. So that's negative 6 times the square root of 9 times the square root of 2. And so the square root of 9, since 9 is a perfect square, the square root of 9 is 3. So you had negative 6 times 3, square root of 2. And so I get negative 6 times 3 is negative 18, square root of 2. So you do have to multiply these factors here at negative 6 times 3. And square root of 2 I can't simplify any further, because the only perfect square that goes into the radicand is 1. All right, and so that's what we were saying here. So remember, a square root simplified when the radicand contains no other perfect squares other than 1. Okay, let's look at number 10. So it's not that bad. That's all you're dealing with. So we're just going to look at maybe a couple more examples, and then I think you'll be fine with this lesson, with this topic. All right, so number 10, rather. Okay, number 10. Let's suppose we had the square root of 567. So yeah, so there might be once in a while where the radicand is a larger number than you would normally deal with. But all you got to do is just look at your perfect squares and just find one. Just find one that will divide into 567 evenly. And if you can't find any other than 1, if you can't find any, then you cannot simplify this. All right, so that's 567. Let me make sure that's correct. All right, so let's look at 4. Will 567 be divisible by 4? All right, no. Will 567, will my radicand be divisible by 9? Yep, right here. Okay, and so then the question is, okay, so I know this. I know 567 is 9 times 63, right? And so here's the question, just like we did in the past. Ask yourself this. It helps. Is this the largest, though? Is 9 the largest perfect square? Because I want to use the largest because it helps me. It helps me save a lot of steps. So if I look at 63, besides 1, are there any other perfect squares that goes into 63? And you just got to go halfway, half of 63. So half of 63 is 31. So just try up to 25. Okay, 25. So obviously 4 won't. So look, 63 divided by 4, 63 divided by 9 is 7. So it does, right? Okay, so then that means this. That means that I can write 63 as 9 times 7, correct? 9 times 7. Okay, so now we have this. Okay, so what that means then that I have 9 times 9 times 7. So that means, remember a while ago we said if we have a product of perfect squares, then that product itself will be a perfect square. So I get 81 times 7, right? Okay, and so then the question is this. Was this 9 the largest, or is this 81 the largest perfect square that goes into 567? It's 81. Okay, so you see what I did? All right, so that's the square root of 81 times 7. And I know I can't go any further because the only perfect square that goes into 7 is 1. And so then I'm going to use the product rule for square roots. So that means I can write this as the square root of 81 times the square root of 7. And since 81 is a perfect square, I'm going to get 9 times the square root of 7. Okay? Now, I'm going to say this. Let's suppose you did not go any further than what you see listed first. All right, so you said, I'm going to just use 9 as my perfect square. Okay, so no big deal. We saw that earlier when we did the same situation. But I just want to mention something, though, okay, and that's important. So I know the square root of 567, it is true, but that's going to be equal to the square root of 9 times 63. That's a true statement. Then using a product rule for square roots, I can write this as square root of 9 times the square root of 63. And then since the square root of 9 is a perfect, since 9 is a perfect square, the square root of 9 is 3. But then remember, you always got to ask yourself, is that square root of 63, can that be simplified? So remember, you got to look to see if there are any other perfect squares other than 1 that's a factor of 63. And so you got to go through this process again, and there is. 9 goes into 63, so you got to go further. So now you're going to say, all right, well, that's 3 times the square root of 9 times 7. And then using a product rule again on this part, I get 3 times the square root of 9 times the square root of 7. And the square root of 9 is 3, so I get 3 times 3, square root of 7, and then 3 times 3 is 9, and you're done. There's your answer. So you don't, it helps if you find the largest perfect square. It saves yourself a lot of steps, okay? But if you don't use the largest, you can still get the final answer. You just have a few more steps to deal with, okay? All right, so I think that this should be enough to get you through the basic understanding of simplifying square roots, okay? So that will be the end of this lesson. The next lesson, we're going to look at simplifying, we're going to use a quotient rule in the next lesson. Sorry. This was a product rule, so this focuses on the product rule. The next lesson will be the quotient rule. All right, so that's the end of this lesson.